Record. All right. Happy Friday. Woohoo. Hypothesis testing. So last day, just to review, right, we talked about confidence intervals. The idea behind a confidence interval is that we have a point estimate, right? And then we're trying to build some sort of buffer around that. So build some margin of error on either side. And then we get this interval. And the key part about the confidence interval is the interpretation, right? And so we are always going to use this setup until you start feeling more comfortable, right? So we're 90% confident in this previous examples from just last day. 90% confident that the interval from 0.0683 to 0.1019 captures, right? So that's that idea that we don't know what the population proportion is, but we're trying to kind of get a good idea of what it might be. And so captures the true fraction or proportion. Hey, I forgot a bracket here. There. Of first-time visitors of the site who would register with under the new design, right? And that part, you just talk about whatever population you were measuring from. Yeah? So confidence intervals are going to come up again, but those are the key ideas behind a confidence interval. So today I want to talk about the key ideas behind hypothesis testing. Okay? So let's just 5.3 is on hypothesis testing. Now, hypothesis testing is when we're doing formal testing. So knowing whether two proportions are significantly different from each other, we can do that, right? Was the vote significantly more than the majority, for example, right? And so when we want to establish significant difference, right? So when we want to say, okay, the proportion that voted for Obama was significantly more than 0.5, right? And so when we want to say that significantly, that involves a lot of math in the background, so a lot of stats. Okay, so that's what we're here to do. Okay, so when we want to establish a significant difference, we need to use hypothesis testing. Hypothesis testing is quite involved. Okay, it's very formal, right? And so there are steps that we're going to follow. What's really, really nice is that these are always the steps that you're going to follow, right? What you do in between, right, in those steps is going to change depending on the question that you have, right? And so today we're just going to start by building the foundation, just those beginning blocks, right? And then we'll be able to kind of run it over again and fill in some gaps. And then we're going to run through it again, fill in some cracks, right? So we'll use examples to kind of fill in the cracks. So because it would be way, way too much to introduce every little detail here now, right? So that's why I want to give you a quick overview, and then we'll go over it again with an example. Okay. So hypothesis testing very formal, right? So that's why we need to do it for any sort of research paper that we're doing, right? And so anytime that you want to establish significance, then you use hypothesis testing. So hypothesis testing is very formal and follows the following steps. Okay. step one, you're going to state your hypothesis. I don't know if you guys did, like, I remember in grade 9 science, right? We had to build like a poster board. Like, what's your hypothesis? I hypothesize, right? So I have some idea that this is going to happen. I hypothesize that when I boil water, it will turn into gas, and then we tested it, right? And then we confirmed that, right? And so we're going to have the same idea, except now the hypothesis is going to be in terms of the parameters. Okay. So first step is to state the hypotheses. Okay. We're going to have H, and then this is a subscript 0, H naught is how we read it, or null, right? Null means 0, so, and not means 0 as well. So you can read it as H naught or null hypothesis. Okay. One fact about the null hypothesis, okay, is that the null hypothesis is going to be a statement of no change, okay? And so it'll always have an equal sign in it, okay? At least for our purposes. If you kind of go on in stats, then you can start to get fancy with it. But for us, I want you to always just have an equal sign. Okay, so you're going to write H naught, so it's a H subscript 0, and it's a statement. So you use a colon. Okay, my null hypothesis is this. Okay. H naught is a statement of no change. Okay. Therefore, H naught will always have an equal sign. Okay. Your hypotheses have to be about a parameter. So whatever parameter you're testing. Okay. Hypotheses, oops. And I should have said this earlier, I think, but hypotheses, plural, will always be about the parameter. Yeah. So for us, we're going to have a null hypothesis, and we're just starting with a one sample proportion. And so if I have a sample and I'm looking at the proportion, what do I really want to learn about? I want to use that to learn about the population proportion, which we denote by P, right? So then my null hypothesis is a statement, and it has to be about the parameter, is that P is equal to, and here's where I might lose you, some P naught, where P naught is the value you want to compare your proportion to, right? And so I usually don't introduce that here, but I think just trying something new, it might backfire. Where P naught is the value we want to compare the proportion to. Oops. It's all weird there. For example, right? Did a majority for example, did a majority vote for Obama? Right? Majority means what? Majority means more than 50%, right? And so here, majority, more than 50%. So then here, the value I want to compare to is this 50% or 0.5 as a proportion, right? And so my null hypothesis is going to be that P is equal to 0.5 because it has to be a statement of no change. Okay? We're going to do a lot of practice with this. And so, so don't get too bogged down in it, but I just want you to see it because it's also kind of, it's a lot. So my null hypothesis is that P has to have an equal sign, is equal to 0.5. Okay. If we flip to the formula sheet, what you'll see is, if I can find it, there. I'm not going to copy it yet, but a hypothesis test for P, I actually tell you what the null and alternative hypotheses are, okay, or at least the default, okay? And so you'll have this on the formula sheet, but I just want to introduce it kind of nice and slow, okay? Or fast, probably from where you're sitting. I had a student tell me that whenever she was in class, she was like, "Whoa, stop going so fast! You're going so fast!" But then she'd watch the video and she's like, "Come on, talk faster." So it's all a matter of perspective. Yeah, but I thought it was pretty funny that she told me that. Anyways, you can watch it in double time. 1.5 maybe. 3x. 3x in auto tune. Now we're talking. That's really good, actually. Yeah. No habla español. All right. I'll do it in Swedish. Oh, yeah. Yeah. All right. So we have our null hypothesis. And like I showed you on the formula sheet, we're going to have our alternative hypothesis. Now, the alternative hypothesis is usually the thing that you want to prove, right? Prove or disprove. So it's the thing that you're interested in, okay? But the problem is we can't prove that two things are significantly different, right? Unless we first assume that they are the same, right? And so that's where the null hypothesis comes in, where it's a statement of no change. So you have to assume that there's no difference, right? Until you have enough evidence to say that, okay, yeah, there is a difference, right? And so that's where the alternative hypothesis comes in. So H, shouldn't put them underneath like that. H subscript A, some people use or H lowercase a, but to me that kind of looks like a 0, so I tend to avoid that. Or H1 if you're wild and crazy. Makes sense, right? H0, H1, but for some reason I won't do it. I use a capital A, okay? Which is the alternative hypothesis. Okay. So HA is again a statement, and it's usually the statement that we're trying to prove or disprove. And so it's usually the statement we want to prove or sometimes disprove. Okay. I think it's pretty reasonable to say that if my null hypothesis is about P, my alternative hypothesis should probably also be about P, right? And so that's, I don't think I'm off base there. We have to, if I start with one hypothesis, I have to hypothesize about the same thing, right? And also in terms of the number has to change, or that'll throw you off, stay the same, right? And so how does P compare to 0.5? The only thing that's going to change is the equal sign, right? Now it's going to be either not equal to, or greater than, or less than. We're going to have three options, and those are going to depend on the question, right? So depending on the question, you're going to pick the sign. Okay? And so in terms of the example, your alternative hypothesis, if I want to know, did more than 50% vote for Obama, right? Really what I want to know is, can I say that P is actually greater than 0.5? Yeah. So here, notice HA must be about the same parameter and value, right? Or maybe I'll say it like this. Instead of saying what has to be the same, notice only the inequality changes from the null hypothesis, so from H naught, changes from H naught. We're gonna have some options are that HA is that P is not equal to, and I'm gonna use that generic P naught, okay, where if we have a naught on a parameter, it's usually just a placeholder for a number. Okay? And so P is not equal to P naught, right? P is not equal to 0.5, okay? Or P is less than P naught, or P is greater than P naught. Wait, these are what we call one-sided tests. And this is a two-sided test. That's going to be important later in step 3. Okay? Keep track of what type of test you have. So a two-sided or one-sided test. In terms of a default, if you're unsure, then just use not equal to, right? It would be really bad if you said it was less than when it should have been greater than, right? If you're ever unsure, then this is the default. And so that's why I have it on your formula sheet, right? You can change it depending on the question if you're comfortable, right? But as a default, use not equal to. Okay, there's a lot more to say, but let's move on to the second step. So we've stated our hypotheses. How does P compare to some value, right? And then, so what do we want to do? I have a sample proportion, right? And I want to compare it to this hypothesized proportion, right? Is P equal to 0.5, right? And so now the second step, step 2, yeah.
So is this like the null hypothesis that I studied in undergrad? Like, compare some hypotheses, like there is a statement in null hypothesis and there is alternative hypothesis. So let's say according to this hypothesis, this drug works on this disease, but according to, so we are comparing with null hypothesis. Is that the same or is it just different statistical?
It is the same, but we're gonna focus on talking in terms of the parameters, right? So the population proportion, the population mean, right? The two population proportions when we move into two proportions, that. So we tend to focus on just kind of, yeah, in terms of the parameters.
Because I studied this back then, where it's kind of same. The theory is same,
Mhm.
but I think we're playing with the numbers now.
You can write it in words, but I don't want you to. Okay, so the second test, or the second step, I call it do the test. It's kind of big. I always say do the do afterwards. Do the test, do the do. Mountain Dew, not a sponsor yet. Do the test is big. What I should be saying here is calculate the test statistic, but it just doesn't have the same ring to it. Right? Sounds boring. Do the test sounds fun. Okay. So this is where we calculate how far the statistic is from the null hypothesized parameter. Okay? From the null hypothesized the reason it's the null hypothesized parameter is because we do all our testing assuming the null hypothesis is true, right? We're talking about a single proportion. How does it compare to 0.5? Well, if I want to show that it's greater than 0.5, first I have to assume that it's not different from 0.5. It just is 0.5, right? And then if I can show that, well, it's really far from 0.5, right? How can I do that? I can calculate the z-score, right? I can standardize it, see how far it is. Okay. Then if it's really far from 0.5, that gives me enough evidence, right, to say that, well, actually it is different. Okay. So that's where we're headed. But the reason we use the null hypothesis is because we do all our testing assuming H0 is true, right? And remember, H0 in this case is that P is equal to P0, right? Where P0 is a number. So I'll say doing the test, I'll say generates a test statistic, which is hard to say, such as a z-score, right? So generates a test statistic such as a z-score, right? If I want to know how far p hat is from p0, right? What can I do? Okay, well, I need, so for one sample proportion, right, Z, if I want to know how far is P hat from some hypothesized proportion, but then I need the standard error of P hat. And I'm not using the formula that we used earlier, so yesterday, on purpose, because it's going to change just a little bit, right? I'm going to hold off. I'm going to move on to the next step so that we can see it all, and then I'll fill it in, okay? But as a clue, right, when we calculated, so before, just so we kind of know where this is headed, before we said that the standard error of P hat should be PQ over N square rooted. And then we said, well, I don't know what P is, so I'm going to use P hat Q hat. But now in hypothesis testing, right, we do all our testing assuming the null hypothesis is true. So now what we're going to do is we're going to say, well, if the null hypothesis is true, then I know P is equal to P naught, right? So that's the only change here. So the only change here is that P hat Q hat turns into P naught Q naught. Okay, maybe I said it. It wasn't so bad. Maybe I can clean up this arrow. So messy. Oh well. Say that again, sorry.
The P hat becomes P naught minus P naught and standard error. That's 0.
No, because if you have 0.5, is that what you mean?
No, like you change the P naught, P hat in that standard error, and the P naught by Q naught by
Yeah.
the Z score. It's like P naught by P hat minus P naught. So, and we input that P naught into the P hat in that Z score.
No, because you still want to see how far is your sample proportion from the hypothesized proportion, right? So what we're saying is, okay, assuming that the null hypothesis is true, that P is P naught, how rare would this sample proportion that I saw be, right? And so the Z tells us, okay, this is rare, or this is rare, or this is not rare, right? But of course, so that's, I'm going to parking lot that for a little bit longer. But now, I wouldn't be happy with communicating with Z scores. They don't mean a lot to a lot of people, right? And so what we need to do to really formalize this is turn that Z score into a probability. Okay, and so now we're going to, step 3 is going to be find the p-value. Okay. Find the p-value. Now, the p-value is going to be really, really important, but it is also very confusing for a long time for a lot of people. So just stick with it, and eventually just kind of, I would recommend, so for me, it works if I memorize the definition of the p-value, and then one day it'll click, right? But at least I can rely on my memorization, and then until I can take the training wheels off. Easy for you to say, Emily, memorize it. Yeah, right. Isn't that what learning is? It is. Some might argue it is. Until you don't have to memorize it anymore, it's just ingrained. All right, so the p-value, let's start there. The p-value is the probability, okay, let's start there. The probability of finding a statistic as extreme or more extreme oops, ugh, made a mess here, or more extreme than what we found in our sample, assuming the null hypothesis is true, assuming H naught is true. Okay. So there's that assumption that H naught is true coming back into play, right? But that's what we use to calculate Z, so it's not that strange. Okay. Okay. Let's break this down. So the probability, remember, probability means that it's an area under the curve. Okay, area under the curve. Under the normal curve in this case, at least for chapter 5 and chapter 6, of finding a statistic as extreme or more extreme. What does that mean? It means it's the area in the tails, right? Area in the tails, potentially 1 or 2. I'll explain again, right? But I'll say it here, depending on your alternative hypothesis, right? Did you want to know that if they were just significantly different from each other, then you take into account both tails, right? Greater than you, then you only really care about one tail, right? Less than you only care about the one tail. Okay. So it's all a big puzzle. Okay. Okay. So in terms of, right, what does this look like? If the conditions are satisfied, and I haven't mentioned the conditions, but I'll bake them in with an example. Okay, so, but they're the same, right? Do I have a randomly sampled, do I have randomly sampled observations so that I can assume independence? And the success failure condition, right, is it satisfied? I'm avoiding it because it changes slightly, right, with the hypothesis. Again, because we now have P naught. Okay. But what are we doing? So what we've said so far is that we assume that P is equal to P naught, right? So we assume that it's centered on P naught. Okay. Then in our previous example, maybe we had a sample proportion of, I don't know, 0.54. I don't know. So some P hat here. Oh, bump that down. So my sample proportion, right, is going to be up here in the upper tail, right? We'll just focus on the upper tail for now. So then the P value, right, is the area under the curve, right? And it's specifically the area in the tail. So the probability is the area under the curve of seeing something as extreme or more extreme, right, than what you saw. And so here, this is the P value. We've worked on finding those areas, right, or at least approximations, and then we use software for more precise values, right? But we know how to find these areas, and it was for this, right? And so, right, what would you have to do? You would first need to calculate your Z score, which conveniently is step 2, right? You're going to have your Z, and then you use it to find the area in the tails, potentially. Right. Okay. I'll leave that there for a little bit. Step 4, and I'll say I only do 4 steps because that's just how my brain works best. I like to have just kind of a condensed list. You could probably break it down into 9 parts if you wanted to, and some textbooks do, and but I stick with 4, although my 4th step has 3 parts. So you have to remember that there's 3 parts, but so then all of a sudden we're ready for the conclusion. Okay. So the conclusion is going to have three parts. The conclusion has three parts. I just lump it all into one because it's all a thought process. Okay. So I'm gonna write out the conclusion and then I'll break it down into the three parts. Okay. So how it's gonna go is that if the p-value, so if this probability of seeing something as extreme or more extreme is small enough, right? Meaning that your p hat is really far away from your p naught, right? Then that's evidence against the null hypothesis, right? And so if the p-value is small enough, and I'll put it in quotes, meaning less than the alpha level out of nowhere. Alpha is just a little Greek fish letter. It's pretty fun to write. Okay. So less than the alpha level, usually the question will tell you what alpha level to use. Okay. But the default is 0.05. So if the probability is less than 0.05 or 5%, right, then we've decided that, okay, then we have enough evidence to reject H naught in favor of HA. So then we have enough evidence to reject H naught in favor of HA. The alpha level. So this is alpha. It's the significance level, but I'm not calling it that. No, it's all new. Yeah, and I'm being a little flighty on purpose because again, we're going to build it out more, but we just need to kind of have the overview. Okay, so but there's no harm in adding it here. This is the significance level. Okay. So we have some borderline where, okay, if the p-value is smaller than this, then I can reject H naught. Okay, and in terms of your conclusion, right, these are the first two parts. But then, of course, if I'm able to reject H naught in favor of HA, that means something in terms of the question, right? So then, of course, the last piece is to state the conclusion in terms of the question. Okay? And so state the conclusion in terms of the question. Okay. This is the only way that you should write your conclusion. Okay, I don't want you to see, I don't want to see anyone kind of getting fancy with this. Don't worry, it's not plagiarism. I'm telling you to use this format. Okay, you don't have to put a spin on it or anything like that, because it becomes very dangerous. It's so easy to just add in one word, and it makes it false, and I'll have to take marks off, right? And so I don't want to do that, right? And so don't take any liberties. Just use this format that I'm giving you. Okay? What's the alternative, right? What if the p-value is not small enough? So what if it's not less than 0.05, right? Then we do not have enough evidence to reject H naught, right? And if you're not rejecting it, then you don't have to say the in favor of HA, because it doesn't mean anything, right? And then you can state what that means in terms of the question, right? And so here, let's see here. I'm just going to copy this and paste it. What if the p-value is not less than the alpha level? All right. If the p-value is not small enough, right? So if the p-value is not less than 0.05, usually, then we do not have enough evidence to reject H naught. And usually I just ditch the in favor of HA. And then you state the conclusion in terms of the question, right? Depending on what that means. So I like this because then you can just add the knots and just change it ever so slightly, right? Notice that your conclusion is always in terms of H naught. Why? Because we did all our testing assuming that H naught was true, right? And so I don't want to see any mentions of HA unless you're able to reject H naught, then you can bring it up, right? But, right, so notice, oh, maybe a different color here. Notice the conclusion must be in terms, or must be about H naught. Since we did all our testing assuming H naught was true. Yes, let me just testing assuming H naught was true. There, is that good? Okay. So like I said, I break up the conclusion into 3 parts, right? First thing you're going to do is just compare the p-value to the alpha level, right? Is it less than or is it not less than the alpha level, right? That's your first step. Then your second step is, do you have enough evidence to reject H naught, or do you not have enough evidence to reject H naught, right? And then in terms of what does that mean in terms of the question, right? So here, let's see here. The conclusion has 3 parts, right? And you have to mention all the parts. So what I'm going to do is I'm just going to paste the first one. No, you know what? I'm going to write it out again. So if the p-value is less than the alpha level, so I am going to use that as the baseline. right? Because usually we want to reject H naught, right? We want to show that HA is not true, but the more logical answer, right? And so if the p-value is less than the alpha level, we have enough evidence to reject H naught in favor of HA. And then conclusion in terms of the question. So the first part, if the p-value is less than the alpha level, right? That's your first part. Compare the p-value to alpha. The next part is your conclusion in terms of the null hypothesis. So the conclusion in terms of H naught, you have enough evidence to reject it, or you do not have enough evidence to reject it. And then finally, the one that people love to forget, ironically, is what does that mean in terms of the question, right? Okay. And with that, we're out of time, but we'll start with an example on Tuesday, I guess. So you can look forward to that. I posted an assignment on confidence intervals and point estimates we work on, and we'll keep working on hypothesis testing next week. If you have any questions, let me know. Otherwise, have a wonderful weekend. Oh, and I guess I should stop this recording.